My name's Alistair. I'm an engineer with WaterBiz. We engineer irrigation systems and work on improving on-farm water use efficiency. Today I'm going to summarise the results from the 2013-2014 Healthy Headwaters benchmarking season. So the objective of the Healthy Headwaters benchmarking project is to ultimately achieve water savings throughout the Queensland Murray Darling Basin. To do this, we benchmark irrigation systems throughout the Queensland Murray Darling Basin in regions such as Goondiwindi, Dalby, St George and Texas. So to collect the benchmarking data, we use several different methods. To collect the irrigation water use data from the irrigation systems, we use the Pressurized Irrigation Monitoring System data, which are also known as the PIMS units. So the PIMS units are mounted on the irrigation system and they give us data such as the amount of water that is applied, the run times and sets of the irrigation system, but also the area that has been irrigated on any particular set. The other type of data that we collect include the energy use data, which we collect from the growers at the end of the season. It basically just provides an energy use value for the operations that are used all the way starting from preparation and tillage through to post-harvest. Other data that we collect include the area of the field that is planted, the crop that is considered, and also the effective rainfall in each of the regions during the irrigation season. So since the commencement of the Healthy Headwaters project in 2010, it's progressed through 4 seasons, ending in the most recent season of the 2013-2014 season. So key performance indicators we consider when analysing and benchmarking irrigation data include the Irrigation Water Use Index and the Gross Production Water Use Index. The Irrigation Water Use Index considers the amount of yield from any particular crop and also the irrigation water that is applied. And the Gross Production Water Use Index very similarly considers the amount of yield produced by the crop, but also the total water which is applied. So this is a measure of the effective rainfall and the irrigation water that is applied to that crop. So in the previous season of benchmarking, which was the 2012-2013 season, there was a variable rainfall throughout the regions that were considered. In addition, there were 10 extra systems that were included in the project, which really helped to grasp a holistic view of the Queensland Murray Darling Basin and the overhead spray irrigation benchmarking dataset. Previous crops that have been considered include cotton, sorghum, bean, lucerne, sunflower and sorghum. Similar to last season, there were issues regarding climate throughout all the regions that were considered. Some regions found that there was a large late season rainfall which affected the yields that were produced from the fields both in a positive and negative way. On the other side, we had regions that had a water shortage late in the season, which also affected the yields in a negative way throughout the regions that were considered. Similar to previous seasons, there's been some minor issues in collecting the data from all the regions that we consider. Two of the main sources of these issues are the PIMS units, but also the operations that are happening on farm throughout the season. So with the PIMS units, we found that some of the growers demonstrated a battery failure, which affected the amount of data that was collected. So we either collected partial data sets or there was no data collected at all for that irrigation system. The other issue included crops not being planted in the field that was considered. Or on the other side of things, we had crops that were planted but no sizable yield was produced from that field, so we weren't able to collect any data for that particular field. So what we've found in previous years is that growers find a lot of benefit in talking to other growers about how they improve their irrigation efficiency. So throughout this season, our data collectors have been talking to the growers and trying to get some feedback on how they're going to improve their irrigation efficiency. So later in this video, I'm going to discuss these comments and try and summarise how some of the growers think they can improve their irrigation efficiency in the seasons coming and for other benchmarking seasons. So this graph demonstrates the average yields produced by cotton in the 4 regions that were considered. Dalby showed variable yields throughout the 4-year period. Goondiwindi maintained a high average of approximately 10 bales per hectare. The same can be seen for St George in terms of consistency. Texas was not benchmarked in 2010 and 2011, which explained the explains why there is no data in these fields, although the yields produced from Texas reduced by approximately 2 bales per hectare on average when comparing the last 2 seasons that were benchmarked. Cotton yields are reasonably variable when comparing growers in all of the regions. St. George achieved the highest cotton yield at over 12 bales per hectare, while also achieving the lowest yield at 6 bales per hectare. The average yield from St. George was 9.8 bales per hectare. Goondiwindi showed the highest average yield of 10.2 bales per hectare, which was slightly higher than that of the St. George average. Crops other than cotton that were benchmarked included beans, corn and lucerne for this season. Beans achieved a record high at 3 tonnes per hectare in 2011, whilst maintaining a 4-year average of approximately 2 tonnes per hectare. Corn achieved the highest yield recorded for all crops in the first season of benchmarking at 14 tonnes per hectare. Lucerne, however, demonstrated a constant decrease in average yield for the entire period of benchmarking, with a minimum of 4 tonnes per hectare. As individuals in the 2013-2014 season, the sole corn grower achieved the highest yield of 5.8 tonnes per hectare, followed by the lucerne grower in Dolby. Mung beans achieved the lowest yield of 1.5 tonnes per hectare. This grower was also located in Dolby. The soybean grower in Dolby achieved the highest bean yield for the season at 4 tonnes per hectare. Looking at the cotton gross production water use index, we can see that in Dolby, the greatest water use index was achieved at 1.1 bales per megalitre, whilst the lowest was demonstrated by another Dolby grower at just over 1 bale per megalitre. The same participant in Dolby used the highest amount of water at 1450 millimetres. Goondiwindi and St. George participants demonstrated a strong average water use index at approximately 1 bale per megalitre. When we consider the irrigation water use index again, we can see that the Dolby grower achieved the highest water use index of 2.7 bales per megalitre. This grower also used the least amount of irrigation water at 445 millimetres. Overall, Dolby achieved an average water use index of 0.9 bales per megalitre. However, the greatest average water use index belonged to St. George with 1.27 bales per megalitre. Texas finished the season with a water use index of 0.2 bales per megalitre and the maximum irrigation water applied of 1,050 millimetres. When considering the results for all the other crops, excluding cotton, we can see that corn achieved the maximum gross production water use of 1.7 tonnes per megalitre, using a total of 378 millimetres of water. In Dolby, lucerne achieved the second greatest water use index of 0.57 tonnes per megalitre. In St. George, the mung bean grower demonstrated a water use index of 0.28 tonnes per megalitre. If we now focus on the irrigation water use index, we can see that again corn achieved the highest value. The soybean grower used the greatest amount of irrigation water this season, yet still maintained a considerable water use index of 0.5 tonnes per megalitre due to the yields that were produced. This amount of water was used by the Texas lucerne grower with a total of 290 millimetres and water use index of 0.8 tonnes per megalitre. Meanwhile in Dolby, the fellow lucerne grower achieved the second highest water use index of 0.9 tonnes per megalitre. So we'll now talk about the energy usage for the cotton growers this season. This of course is an important factor in benchmarking the operations that are used during a season. The greatest energy cost per bale was demonstrated by a Dolby grower at $126 per bale, followed by the Texas grower at $99 per bale. Consequently, the greatest energy use per yield was achieved by the same Dolby grower, who used 4.1 gigajoules per bale. Elsewhere in Dolby, the minimum energy use per yield was demonstrated at 0.2 gigajoules per bale. In Goondiwindi, the greatest energy use per hectare was 12.8 gigajoules per hectare on a large planted area of approximately 170 hectares. This graph shows the same energy use data for all other crops excluding cotton. The standout in this dataset was the corn grower in Dolby using the greatest energy per production at 3.9 gigajoules per tonne. However, the maximum energy use and cost per hectare was shown by the Dolby soybean grower at 3.8 gigajoules per tonne and $116 per hectare respectively. These values are very closely followed by the lucerne grower located in the same region. Whilst maintaining the lowest yield, the mung bean operator in Dalby achieved a cost per hectare minimum of $11.2 per hectare. This pie graph represents the average energy use for each operation for all the growers this season. The main highlights is that the irrigation energy use achieved 44%, followed by preparation at 20%. In most cases, we found that irrigation was the greatest use of energy during the season. This is normally the case for growers using overhead spray systems. Looking at the energy use for cotton growers only, we can see once again that irrigation uses the most energy at 44%. In this instance, post-harvest and harvesting operations each utilise 17% of the total energy. One of the main reasons post-harvest has an increase in energy usage compared to the previous graph is that whilst growing cotton, operations such as mulching and root cutting can often use large amounts of energy. The energy use for all the other crops differs noticeably when compared to cotton. Irrigation once again provided the largest energy use. However, on average, little to no energy was used during post-harvest and in-season activities, which is the main difference when we compare these crops to cotton. In particular, mung bean fields don't require the amount of post-harvest attention as cotton fields. This can be considered as one of the main advantages of growing beans instead of cotton. I will now discuss some general comments which were collected from the growers throughout the Queensland Murray Darling Basin. So, this is mainly just to give growers a bit of an idea of ways they may improve their irrigation efficiency and their on-farm water use efficiency. As I mentioned earlier, a lot of the regions found that there was a late season water shortage, which really affected the yields that were produced at the end of the season. So what some of the growers have proposed is that they will apply more irrigation water at the start or beginning of the season to wet up the soil profile, and this will allow evaporation not to take as much effect as it does during the summer, and also allow the crop to have its roots go deeper into the soil and allow sizable yields to be more productive. Growers that were using centre pivots to irrigate their fields often used half circles for irrigation, and the big issue with this is that with water being applied near the wheel tracks, you can get a lot of bogging near the tracks, and this can cause issues in-season activities but also post-season activities. So what some growers are looking to do is to try and find methods to reduce the amount of water that is irrigated near these areas so you don't get this issue of bogging. And bogging of tyres and also creating deep tyre tracks is really not very good for irrigation water use efficiency, because a lot of the water can be lost through seepage into the irrigation field. And the other issue is that late in the season, when you're trying to harvest the crop from the field, you have to travel slower with your equipment because the bogging and the deep tyre tracks really causes an issue with trying to work the field in that manner. So that concludes the summary of the 2013-2014 Healthy Headwaters benchmarking project. On behalf of WaterBiz and DNRM, I would like to thank all the growers who participated in the season, and thank you very much for allowing us to collect the data, which included irrigation data but also energy use data throughout the irrigation season. If you have any questions, please don't hesitate to contact me. Otherwise, I'll see you in the next season of benchmarking.